Welcome back to day 2. We're continuing to talk about the moon, its phases, and tides. And I wanted to start out by giving you a few facts about the moon. So, the moon is the only natural satellite that orbits the Earth. The moon rotates on its axis, a lot like the Earth. Over the course of 29 and a half days, the moon shows us several phases, and there are actually 8 of those phases or faces of the moon. And what we see from the moon is actually based upon the relationship between the moon, the sun, and the earth. So we're going to learn a little bit more about the moon and its phases in this video, this next video. And if you want to go back and rewatch the video, again, you can do that by clicking on the link and logging into Discovery Education.
During the 29 days it takes the moon to orbit the Earth, the moon appears to change shape from one day to the next. These shapes are known as the phases of the moon. Of course, the moon doesn't really change shape, it only appears to. The reason this happens is because the moon does not give off any light of its own. It only reflects the light of the sun. What we are seeing during different times of the month is the amount of sunlight being reflected off the moon's surface. How much light we see on the moon depends on the position of the Earth, Sun, and Moon as they spin through space. The phases of the moon are based on these positions. The first position and first phase of the moon is called the new moon. During this time, the moon is positioned between the sun and the Earth so that the unlit portion of the moon is facing Earth. In this position, the sun cannot shine on the moon, so the sky appears dark and empty. On the night after the new moon, the lit surface of the moon appears as a slim crescent in the sky. It grows or waxes until we see half of a full moon. This phase is called the first quarter because the moon has rotated 1/4 around the Earth. As the lit portion of the moon continues to grow, it becomes a gibbous moon. This is the phase after the first quarter, when the moon looks large in the sky but is not yet full. The full moon comes about 7 days after the first quarter. At this time, we can see the entire face of the moon. In this position, the moon has rotated halfway around the Earth, allowing the sun to shine brightly on the moon's surface. The night after the full moon, the moon begins to wane or get smaller in the sky. The moon goes through the gibbous phase again and then appears as a half moon. This last phase of the moon is called the last quarter because it is 1/4 of a rotation away from the new moon. The moon continues to wane until it seems to disappear completely. The rotation of the moon around the sun is complete. The sky appears dark, getting ready for the new phases of the moon in the coming month.
All right, so what did you learn about the moon from that video? Well, I learned that the moon does not make its own light. It actually reflects light from the sun. I also learned that we see phases in relationship to the sun and the way that the sun is shining on the moon. The waxing phases are the phases where our moon appears to be growing, and the waning phases are when our moon is decreasing. And I also learned by watching that video that our moon actually has a pattern to the way that it changes. So it has a growing pattern and a decreasing pattern. All right, so the next question that's going to guide our instruction is, does the moon have any impact on the Earth? We're going to watch another video and learn more about how the moon, if it does, has any impact on the Earth. Let's take a look.
One of the moon's most noticeable effects on Earth are ocean tides.
Tides are the regular rise and fall of the ocean's level. In the open ocean, high tide raises the water level about 3 feet or 1 meter over the low tide. Along coasts, tide levels vary because of coastline shape. In particular, shallow bays concentrate water into a small area and increase tide height. The world's highest tides, reaching nearly 45 feet or 15 meters, occur in the Bay of Fundy on Canada's east coast. The moon creates tides through its pull of gravity. This pull is not enough to affect Earth's crust much, but it is enough to cause a distinct bulge to the ocean. To appreciate the strength of gravity, feel how heavy a single bucketful of water is. Then, consider that the moon at any given moment is lifting a sizable portion of the world's water. The high tide ocean bulge always stays with the moon as Earth rapidly rotates below once a day, and as the moon travels around Earth about once a month. From high above the North Pole, we can compare the progress of the high tide to our rotating Earth and see the big difference in speeds. As we'll learn later, this difference in speeds has important consequences. We also can see a second ocean bulge on the backside of Earth. This is water less affected by Moon's gravity because it is farther away from the Moon. When this backside bulge passes by, it creates a second high tide for the day. So every day, ocean coasts have 2 high tides and 2 low tides. The time at which high tides occur changes slightly every day. Remember, as Earth spins, the Moon moves in its orbit around Earth. So by the time this point on Earth circles around again 24 hours later, the Moon has moved ahead to over here. High tide at this point will have to wait until Earth catches up with the Moon, roughly 50 minutes later. Also, long ago, scientists noticed high tide bulges don't travel exactly in line with the Moon. They travel slightly ahead of it. Why? As Earth spins around quickly below the ocean bulge, friction between Earth and the water pushes the water ahead of the Moon just a little. Over long periods, this friction and the timing difference between the Earth's rapid rotation and the Moon's slow orbit affects both dance partners. In particular, astronomers calculate that every century, because of the Moon's pull, Earth's rotation takes about 1/500th of a second longer. A billion years ago, a day on Earth was only 19 hours instead of 24. In another billion years, a day will have stretched to 30 hours.
All right. So after watching that video, what did you learn about the impact that the moon has on Earth? Well, the biggest takeaway that I have from this video is that the moon causes our tides here on Earth. And tides are the rise and the fall of the ocean and our rivers. I also learned that tide levels vary in shallow areas. So for example, in that picture that I showed you on day 1, we saw an area where at one point in the day, you could walk out into the ocean and literally touch the ocean floor. And then later in the day, the water was deep enough for kayakers and swimmers to swim in the water. Then later again, there was an area where someone could walk and touch the ocean floor again. This must have been an area that had a shallow bay or a shallow inlet so that the tide levels varied so greatly that the water was very, very shallow and then very, very deep again. I also learned that there are two high tides each day on Earth, and there are two low tides each day that we experience in our ocean waters. Have any of you ever gone fishing? What time of day is the best time, or what type of tide is the best type of tide for you to fish in? Would it be high or low tide? That's a question for you to think about, and you might want to even do some research on that topic. I also learned that the moon creates our tide because of its gravitational pull on the earth. And at certain times of the day, the moon is literally pulling the water on earth closer to it. And that creates our tides, or the tides that we see on earth. All right, so now it's time for you to do some exploring. And I'm actually going to exit out, and we're going to go back to your journals. So we're on day 2, and I want you to don't forget about doing your observations of the moon. Continue to do that. But we're now on day 2, so you're going to do some exploration in our Gizmo activity. So what you're going to do is you're going to log into Gizmo on your computer. You're going to launch the Gizmo. And then you're going to use this information to help you explore and better understand tides. So if we go back to our journal, it says in our prior knowledge question, what is happening in these images? Well, I kind of gave you the cheat sheet for this because we watched a video about this and we talked about what could be happening here. I'm not going to give you any answers, but we've kind of already discussed this. Then for your warm-up, it says, set the speed to slow, select the bar chart, and press play. What do you notice? So I would go to my Gizmo, I would set the speed to slow, I would select the bar chart and press play. So I'm going to set my speed to slow, select my bar chart, and I'm going to press play. What are you noticing? I'm not going to give you the answers, but I want you to think about that. Then I would go through, I would read the next part that says the changing depth of water is due to tides. Click pause when the water is at its highest level. This is called high tide. What is the height of the water during high tide? And you would actually do some measuring, and you can use the bar chart, chart to help you do that. So I want you to go ahead and go through this Gizmo activity, and it will really help you better understand and explore tides. Then when we get to day 3, which is our mission, if you will, on Friday, I want you to show what you know. There are some great interactive games and quizzes, if you want to call them that you can do. And these are on Boom Learning. And the links have been provided for you, as have the pins. And what you're going to do is you're going to go to Boom Learning and you're going to play these games. So when you click and you put the pin in, you should come up with something that looks like this. And it will ask you several different questions. And I'll just kind of give you a glimpse of what you're going to see. You can also go and play the second game or quiz. And again, it's going to give you some questions. You might have to drag and drop or click on the answers, but it will tell you if your answer is correct or incorrect. So for example, this one says, choose all of the following made of gas. Which ones do I think are made of gas? I'm gonna say the sun, and I'm gonna say Saturn. Let me see if I'm right. I'm correct. So this is what we want you to do. I want you to go through, and you might have to do a little research, but this is actually designed to stretch your learning and to stretch your understanding. So I hope you have fun playing those interactive games on Friday. And I look forward to seeing more of you guys in week 10. And I hope that you've learned so much in the last couple of weeks. Have a great day.